so today we're going to learn how to name ionic compounds. And there are kind of three main rules and a couple smaller rules inside of a rule for naming ionic compounds. Step number one is to name the cation. The cation is the positively charged ion in the molecule. So your cation can be either a metal or a positive polyatomic ion. So a positively charged polyatomic. Alright, so if it's a polyatomic, you just name it. So you just name the cation. If it's a metal in group 1 or 2, you'll just name it. Lithium, beryllium, magnesium, barium. Those are all group 1 and 2 metals, so you'll just name those. If it's a transition metal, however, like iron, then you'll need to put its oxidation number in parentheses, because the oxidation numbers of those particular elements can vary. If your positively charged cation is bonded to just a normal element, so in this case that normal element would be any non-metal, then you name the non-metal but change the ending to "ide". So if it was hydrogen, you change it to hydride. If it's chlorine, you change it to chloride. There's no hard and fast rule for where the ending of an element occurs, so you'll just have to kind of play with it and see what sounds correct, and eventually we'll get the hang of it from doing so many of these problems. Alright, part 3, if it is bonded, so if your positively charged cation is bonded to a negatively charged polyatomic ion, so these ones will have to be negative, then you just name the polyatomic ion as is. So let's do an example problem. If we have NaCl, step 1 tells us that we name the cation. In this case, it's just a metal. Sodium is our metal. So we name it sodium. Then we move on to step 2. If it's bonded to just an element, which it is, it's just bonded to a single chlorine, we change the ending of the element to "ide". So rather than chlorine, we have chloride. And NaCl becomes sodium chloride. Alright, we're going to work 2 more example problems that are slightly more complicated. Oops. Sneak peek at the answers. Alright, so first off, we have Fe. Fe, as you'll find on your personal periodic tables, is iron. But as you'll also notice on your personal periodic tables, iron is a transition metal. Because iron is a transition metal, we're going to need to put its oxidation number in parentheses. But we've got to figure out what iron's oxidation number is. So, the way we figure out what iron's oxidation number is by identifying what it's bonded to. Iron is bonded to chlorine. Because chlorine is a halogen in group 7, it wants to gain 1 electron to have a complete octet. If it gains 1 electron, it has a -1 charge. Noted up here. However, we have 3 chlorines. So overall, 3 times that -1 for our 3 chlorines gives us a -3 overall charge. In order to cancel out that -3 charge, our iron must have a +3 charge. So we write the charge inside the parentheses as iron 3, and then we continue naming an element, chlorine, but we change the ending to "ide", iron 3 chloride. Final answer. The last problem we have is we have Li3PO4. Li is lithium, so we can just add lithium there. And if you'll notice, back on step 3 here, really quickly, now that we've named our cation lithium, we can name the polyatomic just with the polyatomic's name. So, we have lithium phosphate. The reason we had 3 lithiums is because, as you'll remember from your polyatomic ions, the phosphate has a -1 charge, has a -3 charge. So in order to cancel it out, lithium has only a +1 charge on its own, so we needed 3 lithium in order to cancel out the -3 charge of phosphate. Because lithium is a group 1 alkali metal, and all the group 1 metals have a +1 charge. That's ionic naming.